Let's wait for 2 more minutes because people are still joining. I can see the numbers still are more. So please let me know if all of you can hear me. Fine. Yeah, okay. Thanks. Yes, okay. Okay, okay. Thank you. Okay, it's 6:05. We can start now. Let's see if others are joining. Let me just share my screen. Okay. So, right. So, hello everyone. Welcome to week 6 of these problem solving lectures. So, as you probably all know by now, these are sessions meant for you to have some practice solving problems so that you're better equipped to handle your assignments and your assignments and programming assignments and quizzes and so on. Just give me 1 second. I will just get my phone so I can monitor the chat while I do this. Okay, fine. So as usual, all these sessions are, recorded, and the videos and PDFs and programs discussed have been made available to you. I think there's a Google Sheet that has been shared with you. And other than that, sorry, I don't know why. Okay. I also make the links available on my website. So this is the URL. Just save this URL and I basically save all the links there. Other than that, you can always mail me throughout the week. This week was a little busy, so sorry if I missed any mails. I noticed that some mails went to my spam, for example. So in case I haven't replied to any mail over mail, you can just bring up any issues you have right now, and we can discuss that, or towards the end of the class or something, and we can discuss that as well. So let me just open the chat on my phone so that I can check it at as we discuss. Okay. So yeah, these are the usual things. I think we can go on to the session. Unless anyone has some pressing question or doubt, we can go on to the session. Okay, if not, I'll just mention that I have, as usual, muted everybody. I've just disabled mic for people because of, this noise from the background noise was causing like echo and irritation kind of thing because it's a large meeting. But in case people do want to ask questions orally, please let me know in the chat and I will enable mic access for you. So yeah, okay, fine. Okay, then let's go to this week's session. So, this week in your lectures, you have seen about recursion, which is a very important and powerful tool in programming. It's a very simple concept, but it has a lot of very important appeal, and it takes a little bit of time to get used to it. So, it's important to do a lot of problems. As I said, the surefire way to learn programming, any type of programming, is to do it yourself. I'm sorry if there's a lot of noise in the background, by the way. It's like raining. It's raining quite heavily here, so that's why there is some noise in the background. Sorry about that. Apart from that, you saw about tic-tac-toe and ciphers, for example, and some fun stuff like that as well. Okay. So, before every session, I flash this slide, which I don't know if you guys are sick of it by now, but it is very important, and that's why I keep showing it. Which is that when you are coding, please make sure that you write not only write effective code, but you write good code in the sense that you write nice variable names, function names, using comments, white space effectively, using indentation, consistent formatting, all these things so that few months from now or if you give your code to someone else it should still be a very good and readable code. Okay, so that's a goal is to not just write a code that does something. We want to write a code that is understandable so that we don't have to face any issues in the future. So right, otherwise you will be later if you want to use that code for some other purpose you will be breaking your head trying to find out what variable xyz and zyx mean. So give them proper names. Okay, great. So let's go to recursion. As I said, recursion is very simple concept to define, but it's more difficult to implement and understand, and it's a very subtle concept. It's a very powerful tool. So recursion, so we've already seen how computers can make our life easier through programming, which is that computers can do repeated tasks very effectively, right? And this is the famous example that I keep giving is printing numbers from 1 to 100 or summing up numbers from 1 to 100. Or say even 1 to 100 may be doable by us in a minute or something, but say 1 to 1 million, that will not be so easily doable by us if we do it brute force, right? If you use some formula and stuff, you can do it in a matter of seconds, but for a computer, even the brute force method will take only not even a second. This is because computers are very effective at handling large amounts of numbers and looping over the certain things. So that's why loops and stuff that you have used, conditional loops and other things are very useful because you can run a patch of code that you need to reuse again and again in a specific number of times or until a condition becomes false or something like that. Now, recursion also uses the fact that computers are good at doing things, the same thing multiple times, but in a slightly different way. In essence, recursion is when you define a function or a process in terms of itself. So, here, for example, you can see that you're defining a function, right? Some function, and then within that function itself, you're calling itself. So that means that the function is defined in terms of itself, right? So that's what this meme shows, which is that recursion is nothing but pointing to itself, right? So the function calls itself, for example. And the danger with recursion is that when you keep calling yourself, where do you stop, right? You can see that this picture also keeps seems to seemingly go to infinity. That's why in every recursive function, you always need to have a base case, which is that at some point you should stop, right? Otherwise, you'll get an infinite loop. So at some point, you have to say that if it reaches this value, this function should return some tangible value so that the computer or the program knows that okay, if I reach this point I stop. So until it reaches that point it will keep calling itself and keep evaluating itself. So this is the idea behind recursion. Okay, so there are a few famous examples of recursion. You might have also done some in your lectures. Does anyone want to tell me one very famous example where recursive processes are used in programming, for example? Any answers? Factorial is a very famous example because in order to calculate 5 factorial, for example, I need to calculate 4 factorial in order to calculate, because 5 factorial is nothing but 5 into 4 factorial and so on, right? Fibonacci is another one where Fibonacci series is built from taking two numbers and then summing them up to get the next item in the series. Sum of n numbers, for example. So any process where it can be, the process can be broken into a smaller subset of itself, that's a place where you can apply a recursive function, right? So for example, when I want to find, as I said, if I want to find n factorial, I need to first find n minus 1 factorial, I need to find n minus 2 factorial, and so on. If I need to find the nth Fibonacci term, I always need to find the n minus 1th Fibonacci term, n minus second in Fibonacci term, and so on. Sum of n numbers is another good example where if I want to sum up the first n numbers, I first have to sum up the first n minus 1 numbers, the first n minus 2 numbers, and so on. So that is how you think of a recursive process, is you have to break it down. If it can be broken down into a copy of itself, that is somewhere where you can apply recursion. So this is how you think about recursion, is that I can break down the function into doing that function on a smaller set. Okay. So for example, we saw this kind of, not, we didn't do it recursively, but we saw a similar kind of thing when last week we were looking at sorting. There was this instance called insertion. Is it insertion sort or merge sort? I think the last one, selection, insertion sort, I think, where insertion sort, you take a smaller array and you first sort it out and then you add on the elements, right? So that is, we didn't do it using recursion, of course, but you can do it using recursion. So that's what I'm trying to say. Whenever you have a process that can be broken down into doing that process on a smaller subset, that's always a place where you can apply a recursion function. Okay. Great. So I just want to discuss recursion only. The other things like tic-tac-toe and others are like fairly straightforward. So let's just go to the questions and let's try to solve some questions together. As usual, please put your answers in the chat and then we can discuss the solutions. Okay. The first question. So first of all, you can see that this is a recursive function. The reason I know it's a recursive, sorry, the reason I know that it's a recursive function is because I'm defining this function mystery, but within the function call, I have another instance of mystery, right? So that means that this is a recursive function. So if n is a positive integer, what is the output of the function given an input n? So that is a question. Please basically figure out what this function is doing. Please put your answers in the chat. Okay, someone says A, others? I only see three answers in the chat. Any other answers? Okay. Okay, good. I can see that more people are answering. Seems like the majority of people are saying A. Some people are saying B or N minus 1, but most of you are saying A. I'll give another minute in case people are still answering. Okay, I think we can go to the answer. So the answer is actually A. Those of you who answered B, please look at the function carefully. Let's try to understand what happens when I put, say, number 5, right? If I pass in, let's not put 5. Let's put 3. Okay, let's pass in n is equal to 3 into the function and see what happens. So first of all, the mystery of 3 is going to return 3 plus mystery of 2, correct? So now we have to find out what is mystery of 2. So again, it goes back. Okay, in order to find mystery of 2, I have to do 3. The original 3 was there, plus now it will become 2 plus mystery of 1, right? Now again, mystery of 1. Okay, so now I'm going back and I'm saying that, okay, what is mystery of 1? It's going to be 3 plus 2 plus 1 plus mystery of 0. Okay, so now mystery of 0, if I want to calculate, then I find that I have reached this condition, right? N is actually less than or equal to 0 because 0 is equal to 0. So it will just return 0. It will not again go back and calculate what is mystery of minus 1. So this is what I mean by we always need a base case, because you need to stop it somewhere. Otherwise, it will keep on going in this loop and never stop. So always in a recursive function, it's always important to have a base case. So finally, what do we calculate? We calculate 3 plus 2 plus 1, which is nothing but the sum of the numbers from 1 to 3. So that's why it is 1 to 3 and it's not 1 to n minus 1. Even though we put n minus 1 here, we always do n plus mystery of n minus 1. So that means that n plus is already taking care of summing the number n as well. So that's why it's the sum of numbers from 1 to n. Okay, so those of you who answered B, just I hope you understood the logic and where you are wrong. Any doubts in this question? It's a simple question. Okay, fine. Good. Let's go to the next question. So this is an assertion reason question. Assertion reason means, if anyone doesn't know, assertion is a statement and reason will be just the reason for that statement. So your job is to tell if assertion and reason are true or they are false. And if both are true also, is the reason the actual correct reason for the assertion, or is it just some independent statement of the assertion? So this is what you have to answer. Okay. Please put your answers in the chat. Okay, someone says B, someone says A, another person says A, A. Okay, someone says D. Okay, okay, maybe we can go to the answer. In fact, the majority of you are wrong. Most of you had said A. So again, I had explained the question carefully. So please listen carefully, right? Even though both assertion and reason are true, the reason is not really the correct reason for assertion, right? What does the assertion say? The assertion says that if a recursive function doesn't have a base case, it may never stop. This we know is true because I just explained it multiple times already. But the recursion means that a function calls itself is not really the reason why it may never stop, right? Even if there is a base case in this function, the recursive function will still call itself. The reason is without a base case, it will keep calling itself without stopping. So even if there's a base case, recursion is still going to call itself. So R is not really the correct explanation of A. It does not explain A. In fact, R and A are both true, but R is not the correct explanation of A. So this is the answer. Okay. I've already mentioned the link at the beginning of the class. I'll now give you the link at the end of the class because now we are discussing questions. But in case, let's go back to the matter at hand. Is this clear to everyone? Because most of you gave A. So both the assertion and the reason are true, but the reason does not really explain what the assertion is. That's why A is not the correct answer. It's actually B that is the correct answer. Is this clear to everyone? Okay, good. Good, fine. So yeah, be careful in these kinds of questions because they will ask you in such a way that you might get confused. So read the question very carefully. Okay. So what is the output of the following code? Any answers? Okay. Okay. I can see most of you are answering C. Some people are answering B and D also, but most of you have answered C. Okay, I'll give a minute if someone's still answering. 26. Option B. Okay. Any other answers in the chat? Okay, if not, let's go to the answer. So the answer is actually C. Majority of you are correct. So remember that whenever this is one very important thing to remember, and this is why I told you to be careful with your variable names and give them good names and all. As I keep saying in every class, whenever you define a function or a variable, or you name a function or a variable, Python is always going to take the most recent instance of that. So here you can see that initially function was defined as the x squared, but later it was redefined immediately after it was the same name was given to another function, which is x squared plus y. So that's why this definition essentially got rewritten by this definition. So it does not remember this definition at all. So that's why if I put in 5, I can get 5 square plus 1, which is 25 plus 1, 26. So this is why in a big program, for example, if you're going to uh, define a variable to be something and then later you're going to reassign it some other value, Python is just going to forget about all the previous stuff that you did. So be careful that you give unique variable names and you're really clear about what variable is doing what. And that's where it really helps you if you have some clear variable names, like which are self-explanatory as to what they are doing. Okay, so try to do it in that way. So always keep track of your names, and if you really don't want it to be overwritten, you should give different names to different variables. Okay. Okay, next question. So this is a little longer question, but I'll read it out for you. In English, the letter Z usually appears far less than other letters. Imagine applying a substitution cipher, so this you learnt about this week, to a large body of English text where Z is replaced by R and every other letter is also mapped to a unique letter. After encryption, which letter is least likely to be frequent in the new text? Okay, so this is a question. Please put your answers in the chat. Okay, someone says B. Someone says E. I don't know. Oh, okay, you mean C. Okay. I was like, there is no option E. Anyway, someone says B. B, one more. Okay, I can see more B's in the chat. I'll give us a minute more in case people are still working out. Okay, okay. Okay, maybe we can go to the answer. This is kind of like a question where it seems very long, but the answer is in the question. They already told you that Z is the one that appears less. So if I'm going to substitute Z by R and then every other letter also by some other letter, that means that whatever place Z was taking, now R is taking. That means that before, if Z was the one which was appearing very less, now R will be the one which is appearing very less. Because now every letter is mapped onto another letter. So wherever you see R, you have to think of Z, and they already told us that Z is a letter which appears very less, right? At least in the context of this question, we can say that R will be now a letter which is going to be very less frequently used in a new text. Okay, so this is just the answer was in the question kind of question. Is this clear to everyone? Clear? Okay, let's go to the next question. If you have any doubts, please stop me, okay, at any time. Okay, if you have a large cipher, sorry, this is there should be a space. If you have a large cipher text produced by a simple substitution cipher on an English text, can you determine the original message by examining how often each letter appears? Okay, someone says A. I can, okay, most of you are giving A. Nice. Okay, so okay, so I see that most of you have said A. Actually, all of you have said A. That's good. The answer is A. So here, one very important thing is that they mentioned that the cipher text was large, right? So that gives us a large sample size to actually check for, the frequency of letters and compare it with the original English alphabet. If we only get a very short message, then this is not going to be very much useful because we cannot really look for trends of how often a letter is appearing or frequency of different letters and so on. So it really does have to be, since they said it's a large cipher text, then yes, it can be done. Maybe not so accurately, but it can still be done. Okay. So this is an important thing to keep in mind when you think about decodings, messages, and so on. Okay. Next question. Suppose you suspect that a piece of cipher text was produced using a substitution cipher. Under what circumstances might frequency analysis fail to yield accurate results? Okay, I think I accidentally gave the answer away for this because I was, discussing the previous question. So it is, I think this should be easy to answer. There's a multiple select question, so multiple options are correct in this question. Not understood. Okay. So the question is that you have a piece of ciphertext that you think is produced by a substitution cipher. Substitution cipher is what we've been discussing, where a letter is substituted by another letter in the English language. But suppose we did a frequency analysis like what we discussed in the previous question, where you're just looking to look at how frequently letters are appearing and try to see what is the original message from that. But in what circumstance could this model fail? Okay. It does not always have to give you good results. So that is the question. So this is a multiple answer question. So multiple options are correct. So you can check that. Okay. Okay. A and B, B and C, A, B, not C. Okay. You mean A and B. Okay. B and C, A and B. Okay. So maybe we can go to the answer. So the answer is A and B, and I'm surprised that some people are saying C because I at length told you how having a long text actually helps us with frequency analysis. So some questions, please just use your common sense, right? Imagine that you have a very long text, then you can easily pick out that how frequently letters are appearing or so on. Whereas if I have only say 5 letters, from that I can't really tell if a letter is frequently appearing or if it's my sampling bias, right? If I want to make a statement about some sort of statistical significance, I really do need a large sample of values, right? So, for example, if you flip a coin once you cannot really tell if heads and tails are equal probability. Whereas if you flip a coin 100 times, then you can check if it's a biased coin or not by checking if roughly half the time it is giving you 50-50. Like that, if you have a larger sample space, I can always make more certain statements about my case, about a frequency analysis, for example. So that's why if the ciphertext is very short, then my frequency analysis is going to fail. The other way in which it will fail is if it was encrypted with another method before encrypting with substitution cipher. So substitution cipher is not the only cipher that can be done. There are other kinds of ciphers as well, which may be more complicated. So in that case, if some two level of encryption is done, then we won't be able to um, uh, do this. Okay. So that is the idea. Okay. If the variable name, next question, I hope this is clear to everyone. Anyway, if variable dictionary name, is a non-empty dictionary, then what does sorry, there should be an underscore here, I missed it. It's the same as this, okay? So dict name dot values, what does it return? Okay, option C. Once more explain the question, ma'am. This question is simple, right? You have some dictionary. What does dictionary, whatever that name is, dict name dot values, what does it return? That's the question. So we learnt about dictionaries last time, if you remember. Okay, it returns the values in the dictionary. Okay, I can see many people saying C. I'll give a minute in case people are still solving. Both B and C. This is not, it cannot return both the keys and the values in the dictionary, right? Think about that. This is not a multiple select question. Okay, okay, I think we can go to the answer. Most of you got the correct answer. The answer is actually C. Dictionary name dot values returns all the values in the dictionary. So remember that um, uh, that there is, you know, two things. When every dictionary, in a dictionary, data is stored in pairs, there's always a key and an associated values. So if you give dictionary name dot values, it returns only the values to you. Okay, so always there's a key and a value. We saw this last week when we did the questions. So remember that this is one of the ways in which we can store values in Python. Okay, here's another type of assertion reason question. Here, assertion reason question. Again, I'm explaining it again in case someone is not familiar with this format. Assertion is a statement, and reason will be the reason for that statement. It can be that both these statements are true, both these statements are false, or one is true, one is false. But even if both are true, you have to then say whether the reason is actually the correct reason for that assertion, or if it's just another true statement which is independent of the assertion. That's why assertion and reason together you have to check. Okay, fine. So please check this and let me know. Okay, D or C. Uh, this is D and C can't be true. D or C are true, fine. Someone says C. Okay, I can see A, C, B. There doesn't seem to be a clear majority yet. Okay, okay, fine. Maybe we'll go to the answer. I don't see a clear majority answer. The answer is actually A. So Caesar cipher is nothing but substitution cipher, and here every letter is just shifted. So, for example, a very simple one would be if you just shift everything 25 spaces, right? So then A would be replaced by Z, B would be replaced by Y, and so on. So that's just in the reverse, right? So we can look at some examples if okay. Sorry, this is some other stuff that I'm looking at. Caesar cipher. If I search, let's just go to the images, right? So you can see this. For example, if I just shift the alphabet like this, now A is replaced, for example, D is replaced by A is replaced by X, B is replaced by Y, and so on. So we are just shifting the alphabet, and this is a very simple one where it's just shifted two characters to the right. For example, A is replaced by C, and so on. And this is nothing but a substitution cipher, because a substitution cipher is somewhere where we substitute each letter by another letter of the alphabet. So the reason for it being a substitution cipher is because we are just replacing each letter by another letter, and here it's by a fixed shift in the alphabet. It's not a random substitution, it's that every letter is shifted by a fixed amount. So R is actually the reason for A. That's why A is the correct option. Is this clear to everyone? Okay, good. Again, if you have any doubts, please feel free to stop me at any point and I can explain it once again. I think these are simple questions, so you should be able to understand. Just read the question a little carefully and you will be able to understand what it actually is asking for. Okay, so this is a multiple select question, MSQ. That means multiple options are correct. Which outcome generally follows from providing a proper base case in a recursive function? So we have already discussed about base case few times today. So please check and let me know. Okay. Someone says A and B, D, okay, A and B, A and C, A and B, A and B, A and B, A and D, A and B. Okay, maybe we can go to the answer. So the answer is actually A and B. Of course, if the base condition is met, then the function gives a predefined result and it prevents infinite recursion, because if there's no base case, as I said, the function will just keep calling itself forever and then we'll have an infinite loop. Of course, it does not ensure that recursion depth is always constant, just that it stops at the same time, right? So, for example, in your factorial case, your base case would be that 0 factorial is 1 or 1 factorial is 1 also. Either one you can use. In that case, what you do is that you just keep calling until 0. But that doesn't mean that the depth is always constant, right? If I have 5 factorial, then the function calls itself 4 times. If I have 1000 factorial, it's going to call itself 999 times or something like that. So the recursion depth is not always constant just because you have a base case. Also, the last option, I think some of you give D as the answer, but please read the option. This is why I keep saying read the options carefully, because because they are worded in such a way that they might confuse you. Here it says that the base case allows the function to keep calling itself indefinitely. That is exactly the opposite of what the base case does, right? Base case stops the function from calling itself indefinitely, in fact. So please check the question before you answer properly. Okay, so A and B, most of you gave, majority of you gave, and that is the correct option. Okay, next question. In a standard 3 by 3 tic-tac-toe board, how many distinct winning lines, rows, columns, or diagonals pass through the center square? This is a very simple question, which I think all of us can answer, even without computer science, because we have all played tic-tac-toe, right? So please put your answers in the chat. Okay, someone says A. A. Okay, many people saying A. One person says B. D. Okay. Okay, D. Okay, I think the answer is between A and D. I'm kind of surprised. I thought everyone would know this. The answer is, of course, 4. It's not 3. You can have a horizontal win in the center square, a vertical win in the center square, and of course, you can have two diagonal wins in the center square. So that's why the answer is 4. It's not 3. Uh, all of you have played tic-tac-toe, right? X and O, knots and crosses, whatever it's called in your thing. But yeah, it's 4 because one, two, three, 4 lines, 2 diagonals and 1 horizontal, 1 vertical passes through the center square. Is this clear for everyone? I'm surprised that a lot of people got this wrong, actually. I thought tic-tac-toe, I would not have to explain this. Okay, good. Great. Okay, fine. Let's go to the next question. Okay. So the quiz part of the questions are over. Now let's go to the programming assignments. As usual, I will give you some time to solve the question. And please actually try to solve the question. I think last few classes people have been solving and sharing their solutions in the chat, which is very good. Even if you get the solution, don't immediately share it in the chat. Let's share it after 10 minutes so that everyone gets a chance to try it in their own way. Because as I said, one thing about programming is it's a very creative thing, so that everyone may approach the question differently. So let's try to keep it like after 10 minutes, maybe people can answer even if you get it before 10 minutes, just share it after 10 minutes so that people get a chance and people don't just look at the solution. Even if someone posts a solution, doesn't mean you have to look at it, but let's just make it a little interesting. Okay. So here's a question. This is a long question, but whenever it's a long question, you know the question is going to be simple. So let me just read it once and explain to you. I think once I read it, it's self-explanatory, but let's see. You are part of an elite team of treasure hunters, and your latest mission is to find the hidden treasure in a mysterious ancient temple. Inside the temple, you discover a series of enchanted scrolls containing arrays of magical numbers. The numbers are encrypted in different arrays, and each scroll has a clue indicating which element in the array holds the key to the treasure. You are given one of these arrays, and the clue on the scroll tells you that the treasure is hidden inside the kth smallest number in the array. So, your task is to figure out the kth smallest number from the array, where k is smaller than the size of the array, and return it as your answer. The treasure hunters in your team trust you with this task, and the sooner you find the key, the sooner they can open the vault. So, be efficient and answer the question quickly. So, you just have to find the kth smallest number from an array. So they have given a nice example. If your scroll has this kind of array 12, 3, 5, 7, 19, 17, 4, and if you have to find the fourth smallest number in the array, Then the fourth smallest number is actually 3, 4. 3 is the smallest number, 4 is the second smallest number, 5 is the third smallest number, and 7 is the fourth smallest number. So this is what you have to do. So you input a list of n integers and some integer k, where k has to be less than or equal to n, and return the kth smallest element from the array. So it's a very simple question actually. It just looks long, but it's very simple. So all of you please try it. And as I said, let's try to share our answers after 10 minutes so that everyone gets a chance to try the question out. Okay. So like at 7 o'clock, let's share our answers in the chat. Okay. I'll give you some time now to try out the question. And I want everybody, so there are like 30 people in the meeting. Please, all of you try the question once so that it's a very simple question so that we can discuss the answer together. Okay. Any doubts in the question? Everyone understands the question? Okay, good. I can see thumbs up. Everyone understood the question. It's a simple question. Please, all of you try it. If many of you are finished before 7, then we can discuss. But let's keep it till 7 so that everyone gets a chance. Try to actually write the program itself in Python and try to. You're unable to understand. Okay, okay. I can explain it again. Question not visible. Okay, sorry. So here's a question. So you can ignore all this. The question is to find the kth smallest number from an array. So suppose you have this array 12, 3, 5, 7, 9, 17, and 4, and your k is 4. Then that means I have to find the fourth smallest number in that array, right? So here, for example, 3 is the smallest number in the array. 4 is the second smallest number in the array. 5 is the third smallest number in the array. And 7 would be the fourth smallest number in the array. So the answer will be 7 because 7 is the fourth smallest number in the array. So it's not to find the smallest number, it's to find the kth smallest number. Is this clear now? Okay, good. I hope all of you are trying the question. Yeah, we can discuss the question at 7 o'clock. Until that, everyone please try the question. Anyone else who's done? Okay, let's give minute some time in case people are still solving. As I said, I would like everyone to try to solve the question because that is how you learn programming. Okay. Okay, good. Someone else is also done. Let's give 5 more minutes in case people are still trying. Okay. How many of you have been able to solve the question? Can you just raise your hands? Okay, four of you, five of you. Okay, good. Others, are you trying or? Okay, good. Done, done. Fine. Okay, so maybe some of you can share your answers in the chat and then I will also share my answer and then we can discuss. So others also, those who didn't answer, I hope you have tried. If you have not got, that's fine, but at least try the question so you know how to think about it and other things. Okay, let's see. Exactly. So it's a very simple question. I think some of you have already shared the question. So yeah, the simplest way to do this is to just sort the array, and then when we have it sorted, then we already know that the first element is the smallest, second is the second smallest, and so on. And here, of course, one important thing is that if k is greater than n, then we should give some error message. Otherwise, it will not give us a proper answer, right? So this is the so some of you have answered your sent your answers very good. So I will also show my answer. It is more or less the same. Okay, okay, fine, very good. Let me just go to my, okay, sorry, wrong screen. Okay, so this is week 6, program 1. So again, all these programs have also been shared with you guys and in the Google Drive along with the slides of the class. So please, I hope you've been able to access them. Okay. So here is the definition: kth smallest array n and k. Here I'm going to sort the array. If k is greater than n, then I'm just going to print that error message. Otherwise, I'm just going to return the k minus 1 element. So again, it's k minus 1 and not k, because the indexing in Python starts from 0, which you guys know by now. So the first smallest element is at index 0. The second smallest element is at index 1, and so on and so on. So that's why it's k minus 1. It's not just k. Okay, so we can just see if this, and this is of course taking input and getting the inputs and all that stuff. So we can just see if the program works. So let's just give like 2, 4, 5, then 22, 76, 85, 8, and so on. So I want to find the third smallest element. The third smallest element here is 5. So that's what they give. The kth smallest element is 5. So one sec, let me just increase the font size. Yeah. Is this clear to everyone? I think this is a very simple program. Again, those of you who didn't get it, I hope you still tried the question. It's very important to at least try. Writing programs on your own, you will never learn until you write them. Okay? Even these simple programs, it's important to try write them on your own. Even if you feel like you understand, only when you write it, you will really understand all the nuances that are there. Okay, so this is the first question. Let's go to the next question now. Okay. So Alex, a young programmer, discovered a challenge: convert decimal number to binary using recursion. Okay, so you should not use any loops or built-in functions, but only the magic of recursion. So here, your question is to write a recursive function to convert a decimal number to a binary number. I hope all of you know how to convert a decimal number to binary number. In case you don't know, this is how you do it. Okay, you basically divide the number by 2 and then store the remainder, and then you keep doing this with the quotient. That means whatever you get after dividing until it becomes 0. Then you have to read the reminders in reverse order to get the binary number. So for example, if I want to find the binary representation of the number 13, then 13 by 2 is 6 with the remainder 1. Then I take 6, divide that by 2 to find remainder 3. 3 with remainder 0. Then 3 divided by 2 will give 1 with a remainder 1. 1 divided by 2 gives 0 with a remainder 1. So now when I reach 0, I can stop the process when I reach the quotient to be 0. So now the binary format, you have to read it from the bottom to the top. So it's actually 1101 is the binary equivalent of 13. So you have to do this question now. Please explain again first program. Okay. Okay, fine. I'll just explain the first program and come back to this. What do you not understand in the first program? Can you just clarify, because it's not a very difficult program. What is it exactly that you didn't understand? Which step? Okay. You did not answer. I will just tell you. So here basically what we have done is we have taken the array and we have sorted it, right? So when you sort the array, it will come in ascending order by default. So ascending order means from smallest to biggest. We want to find the kth last step where you use. Okay. Yeah, so here basically you can see that sorting is that we are ordering the array from smallest to biggest, so that already it's in that order. So the first element of the array will be the first smallest number, the second element of the array is going to be second smallest number, so on and so forth, right? Third smallest element is going to be third smallest number, and so on. But because the indexing in Python starts from 0, the first element corresponds to index 0, second element corresponds to index 1. So it's going to be what is in the k minus 1 position will give me the kth smallest element. So that's how you think about it. Of course, if k is greater than n, it doesn't make sense to find the seventh smallest element in an array of 5 numbers. So that's why we should write that the clue should be smaller. Okay. So the last part is just, I don't know, this part, I don't know if you mean this part. Here, this is just taking inputs. This we have done many times in this classes. So you can just see that this is, I'm just taking input as a list elements and then splitting it based on the space so that I can just save it all into a list. So this is one of the ways in which to get a list input from a user. Then I'm just running that function. That's all. Is this clear now to you? Okay, I hope it's clear. If not, try running it yourself with some different functions, sorry, different lists, and it will be clear to you. You can run it for first smallest, second smallest, and see what happens. If you want, you can print also. Okay, good. So this is, as I said, this is our next question. We have to now write a recursive function. So remember, no loops, no built-in functions, only use recursion to find how to convert a decimal number to binary. And I just explained how decimal to binary works, right? You have to divide by 2 consecutively until you get 0. And you have to collect all the reminders and print it in opposite order. So 1101 is 13. Okay. So I'll again give you 10 minutes to try this. So maybe at 7:15 we can discuss the solution. So until then, please all of you try. If you're done, don't paste the solution in the chat. At 7:15 we can all paste our solutions in the chat. Okay, someone is already done. Very good. But I'll give some time in case others are also trying. I want all of you to try this question. Before I saw only like 10 people had raised their hands. All of you please try. And again, please only use recursion, no loops or anything. How can you improve your programming is by doing programs. There's no other shortcut or magic cure to this. You have to write programs. You have to sit and write programs. At some point, it was difficult for you to do addition and subtraction, right? When you first learned maths. That time, how did you improve it? You had to keep doing sums and you had to keep doing addition, subtraction, multiplication until you got good at it. Programming was also some skill like this. You have to keep solving problems and you have to solve different kinds of problems and you have to solve them. Otherwise, you will not get the logic. Anyone can copy a program from anywhere, right? Especially now, it's very easy. We can just search any program. Even this program, you can search and you will find for 1 million sites which will give you the answer. But you should actually think about how to do it. So you should use your brain and you should solve it. Then only you will get a hang of programming. So one good way is that during these sessions, take your laptop and try to write a program. Okay. Presentation error is fine. I understand that it's an issue when you try to submit your answers. But if presentation is the issue, then that's fine. If your logic is correct, that is what is important. See, for assignments and other things, presentation might be important. But other than that, to actually get the skill, right? Because try to treat this course as more than an exam. Try to think of it as you're building a skill, right? So in that case, it's always, if you're getting the logic, I would say that's very good. Presentation things, you can take care, be a little more careful when you write the program. You can try running it and see. Okay. So I'll give 5 more minutes in case people are still solving in this. Okay, so I'm so sorry. So yeah, about the NPTEL exam. So I think I've mentioned this before. I am an external person. I am not really working with the NPTEL team who was preparing the assignments or the exams. I am just here to solve these problems for you so that you can get a better handle on how to do these things for your exam. So, any questions about exam format and things, I think it will be better to address it in the discussion forum. Okay, because I don't know about it. So, I don't want to give any false answer because I don't know. So, I am just as clueless. So, in your course page itself, there will be a discussion, Google forum for discussion or something. You can try writing there or you can send a mail to the NPTEL team or something. I am not in charge of conducting exams, so I don't know about this. But I would say that there should be programming. That is, I'm not saying there will be, but I'm saying that it doesn't make sense to learn a course on Python and then have an exam which doesn't have programming. But of course, I don't know how it works. So again, that doesn't mean that I'm saying that there is actually programming in the exam. I'm just saying that it should be there. Okay, good. Okay. Okay, so how many of you have got the solution? Okay, done. Okay, very good. Okay, good, good, good. Fine. Okay, maybe we can discuss the solution then. Give. Okay, okay, fine. So some of you are pasting your solutions. Nice. So again, this should be a recursive function, right? So in your function definition, you should have call the function again. Don't use any loop. I know how to write Python program, but I'm not performing well in the course. Okay, then maybe the issue is something else. Maybe is it that you are not able to format your programs properly? That is also part of writing a program, right? So maybe you can try to, if you're getting presentation errors, then some people were discussing in the past few weeks about how to write proper print statements so that you don't get that error, or you can again bring it up in the forum. Okay, so that's one way to do it. Okay, others are also giving their answers. Good, good. Okay, okay, good. So let's since so many of you have shared your answers already, let me go to mine. Right, so decimal to binary recursive, so these are my base cases, okay, essentially, so I'm just going to mark them. So if my decimal number is 0, I'm just going to return 0. Decimal number is 1, it's just going to be 1. Otherwise, I'm going to recursively call the function with integer division by 2 and then append the remainder of the correct number by 2. So what does integer division mean? So remember that whenever I give two divide signs like this, that gives me only integer division, which means it will only return the quotient without the decimal part. This we've already seen. Okay, let me just clear. Sorry. Okay. So, okay, let me just for those of you who don't know about integer division, suppose I have something like 25 by 2, that is 12.5, right? But if I give 25 double dash 2, then that's going to be 12. So it gives me only the quotient part without giving me the decimal part, right? So that is why it's called integer division. If I want to find the remainder, then I use the modulus function, which is, and the remainder here is 1. So that is the two things which are used here, right? So every time I'm just adding on the decimal number at the end, and then at the beginning I'm adding the second one. So here basically, sorry, and so on. So here basically you can see that after I divide 13 by 2, I have to keep the only the quotient without any decimal or remainder, and then I have to perform the option there. So that's why in my second function call, I call the number now the integer division part of the number, and then I apply the same process again. So let's try to apply this to 13 so that it's clear. So when I first run this for 13, it's going to go here. It's going to say that, okay, 13, to calculate 13, I know that 13 mod 2 is 1, and then at the beginning I have to append whatever is the same thing but for 13 integer division of 2, which is 6, right? So to calculate 6, I again go back, I see here and I say that 6 integer division is 3, and now with the 1 I add a 0 in front of it because 6 mod 2 is 0, and so on and so on. So you have to keep doing it. So the reason is that I add the string at the end and not at the beginning is because that, as was shown in the example, that we have to read the number from bottom to top. So always the number gets added at the end of the number. It's like that. Okay. So that's why the string is written like this. So other than that, it's easy. Okay. This is clear to everyone. So remember that if you ever find it difficult to understand something, then one very sure a program that you can't understand or something, a very surefire way to understand it is just to print it. Okay. So here, if I print it, you will see every step how 13's thing is calculated. So we can actually do that and check. Okay. So if I enter the number now 13, so you can see that in the beginning I had 1. One sec, why is it 1 1? Oh yeah, yeah, okay, okay. So I can say that, let me just print like this. That'll be easy. 6 and like this, right? Oh, sorry, not this. So 1101 was the answer, right? That we got here also. Yes. So let's just run it and see. Yeah. So here you can see that 1, 1, right? 3, then 6, then again this, like that. So that is what is happening here. Okay, so the decimal number is 13. So like that, you keep doing it. I don't know why it shows. I think here it's just showing this plus this together. That's why it looks a little weird. So just ignore this. I thought that the print statement will be a little cleaner, but it's not for some reason. So let's just okay. Fine. So anyway, the number, if I enter 13, I get the answer as 1101. So that's the point. Okay. This is fine for everyone. Did you understand the logic? Okay, good. Again, I hope all of you are trying. That's why I'm giving you time. Otherwise, I can just explain the programs and go. I'm giving you time so that you get a chance to solve it yourself. And I hope you aren't just, searching or something. Okay, next question. So this is an interesting question. Again, it's a long question, but let's read it together and understand what's happening. Okay. So Fibonacci, who some of you mentioned at the beginning, is a young resident of the Italian city of Pisa. He spends a lot of time visiting the Leaning Tower of Pisa, one of the iconic buildings in the city, situated close to his house. During all his visits to the tower, he plays a strange game while climbing the marble steps of the tower. The game. What is the game? Fibonacci likes to climb the steps either one at a time, or two at a time, or three at a time. This adds variety to his otherwise monotonous task of climbing. He wants to find the total number of ways in which he can climb n steps if the order of his individual steps matters. Your task is to help Fibonacci compute this number. Okay? For example, if he wishes to climb 3 steps, in the case of n is equal to 3, he can do it in 4 different ways. Okay. So, for example, 3 steps you can climb by doing it in 3 moves, one step at a time. So, 1, comma 1, comma 1, 1, comma 1, comma 1. You can do it in 2 moves, which first take a single step, then a double step. So, you can do 1, comma 2 or 1, comma 2, 2, comma 1, 2, comma 1, and then 3, which is just doing it in one move. Okay. So, this is how you do it, right? So for another example, n is equal to 5, you have all these kinds of sequence. Sorry, what is happening? These kinds of sequences. So the point is to know that each element of a sequence can only be 1, 2, or 3. So the point is that he can only climb the steps once. We can climb one step at a time, two step at a time, or three step at a time. Your task is to write a recursive function named steps that accepts a positive integer n as the argument. It should return the total number of ways in which Fibonacci can ascend n steps. Note that the order of his steps is important. So the fact that the name is Fibonacci has something to do with it. So please try to read the question, try to figure out the funda, and then do the question. Okay, let's discuss this. I'll give you some time to figure this out. Let's discuss this question at 7:17 now, 7:30. So I'll give you some time. Again, all of you, please try the question. Read the question carefully. This is not such a straightforward question, right? So let's try to understand the question first and then do it. Okay. Any doubts in this question? I hope everyone understood the question. Okay, if there's any doubts, let me know. Okay. Some internet issue. Okay. Someone says they are done. Good. Anyone else? Okay, someone else is also done. Let's give 5 minutes in case people are still trying. Okay, maybe we can answer the we can like check the answer slowly. Okay. So one thing to recognize is that first we have to find out, okay, fine. First of all, I can see that someone has given this answer in the chat. Very good. So if n is less than 0, 0. N is less is equal to 0, then 1, equal to 1, then 1, n is equal to 2, then 2, and so on. So here one thing to understand is this is, sorry, I keep moving to the wrong tab. One thing to understand here is that this is very easily something that we can apply to a recursive sequence, right? Because in order to calculate how many ways to do 5 steps, I have to first calculate how many ways to do 4 steps, how many ways to do 3 steps, and so on. If it's 0 steps, obviously there's 0 ways to do it. If it's only 1 step, then there's 1 way to do it, that I have to just take the step. There's 2 steps, there's 2 ways to do it, right? I can either do it like this, where I take 1 step and then 1 step, or I can do it by taking both the steps together, right? 2 step, when you take 2 step at a time. So that's why there are 2 options, and so on. So, and we already saw that in the case of 3 steps, it's in 4 different ways, right? I don't know why this is like, okay, I'm sorry. I should edit this. This is like this too. Don't worry about why it's there twice. It's actually just 4 ways. So you can already see the sequence actually. For 0 steps, it's 1. For 1 step, it's 1. For 2 steps, it's 2. For 3 steps, it's 4. And then also this is called Fibonacci. So we know that has to do something with the Fibonacci series. So we can see how to solve it. Okay. So let's see the basic idea behind the solution first, which I've written here in the comments. Essentially, the sum of all the steps in a sequence should add up to n. So for example, here sorry, I keep switching to the wrong tab. I'm sorry. But here you can see that 1 plus 1 plus 1 is 3, 1 plus 2 is 3, 2 plus 1 is 3, 3 is 3, etc. For example, if n is equal to 5, some of the examples they have given 3 plus 1 is 5, 1 plus 1 plus 3 is 5, so on. So always you should have a sequence such that it adds up to 5 or n, whatever n is, right? So that's the first thing we have to understand. The last term in any sequence could be either 1, 2, or 3, right? If there are last step as 1 is given by the steps of n minus 1, the number of sequences with last step as 2 is given by steps of n minus 2, the number of sequences with last step as 3 is given by steps of n minus 3. So total number of sequences is steps of n minus 1 plus steps of n minus 2 plus steps of n minus 3. So this is how I calculate it. I basically put in just these are my base cases. If there is 1 step at a time, 2 step at a time, or 3 step at a time, 3 steps again, steps of 1, steps of 2 plus 1, right? So then the function is just that if it's 5, then I just calculate for steps of 4, steps of 2, 3, and steps of 2. So let me repeat again, because I can take 1 step at a time, 2 step at a time, or 3 steps at a time. If I already take 1 step, then there are n minus 1 steps remaining. So now I calculate for that number. If I take 2 steps, then there are n minus 2 steps remaining. So I calculate for that number. If I take 3 steps, then there are n minus 3 steps remaining. So I calculate for that. So, and then I add up all these sequences because any of these sequences are possible. And that's why the order matters. If I first take 1 step, then take 2 steps is different from if I first take 2 steps and then take 1 step. Because both of those are counted differently when I calculate it like this. Okay. So that is why once I take 1 step or 2 step or 3 step, then it becomes a point of solving the sub problem. So remember that recursion is always about solving the sub problem, right? When I have factorial from n factorial, I will break it down into solving for n minus 1 factorial. Similarly here, instead of solving from n steps, I've broken it down to solving it for n minus 1 steps or n minus 2 steps or n minus 3 steps. So that's what recursion is about. Okay. So let's first see if it runs properly for 3. So we already know that for 3, it's 4 steps. Let me just clear this. It's too cluttered. So yeah, if I write 3, I know that I have 4 steps. If I now run it and I run it for 5, I can see that there are 13 steps. And you can actually work this out and see that there are actually 13 sequences for this. And one interesting thing is for 4, it's, oh, sorry. For 4, it's actually 7 steps. So that's how it works, right? So it actually kind of, I think, follows a Fibonacci sequence where it's 1, 1, 2, 4, then 7. No, it doesn't, right? If I can, 1, 2, 4, 7. Yeah, I think it does follow some. I think that's why it was called Fibonacci. I had thought about this. I think it does follow some kind of Fibonacci sequence. Well, we can work it out. But the point is that, okay, Fibonacci or not, this is Oh, it's called Fibonacci. Okay, I didn't know this. Let's see. Let's see what that is. Uh, Again, this paper. Sorry about that. I was working before. So, okay, Fibonacci is the sum series of numbers where each sum term is the sum of the three preceding terms. Oh, okay. So today I learned. So this is actually something called a Fibonacci sequence. Interesting. So yeah, so I thought that this is, yeah, 1 1 2 4 7 13. So this is the version that what we were seeing. So that's why it's a Fibonacci sequence. So thank you from the chat. I was thinking that looks something like a Fibonacci sequence because it had the name Fibonacci in the question, but it was a little different. I didn't know that there is another series called Fibonacci. Very interesting. So everyone understood this question? Again, because recursion is there, it becomes simpler, right? We Recursion is about breaking a problem down into a smaller version of that problem and then solving that problem. So here we have broken this problem down into three smaller pieces actually: steps of n minus 1, steps of n minus 2, and steps of n minus 3. Is this clear to everyone? Any doubts? Okay, if not, let's go to the next question now. Okay, next question is to remove an element recursively. Write a recursive function called delete elements in Python that removes all occurrences of a specified item from a list, creating and returning a new list without modifying the input list. So you have to create a new list and remove all the elements. So suppose your list is 1, 2, 2, 3, 4, 5. If I ask you to remove 2, then you should remove 2 and return back 1, 3, 4, 5. But that should be stored in a new list. You should not modify the original list. And also here it's a recursive function. So you shouldn't use any yeah, you should use recursion when you do this. Okay, so I'll again give you 10 minutes. Let's discuss the solution at 7:40. Okay, good. Okay, please all of you try the solution. Those of you who keep asking that how to do this or all those things, do you know, like, the only way how to get better at programming, the only way is to actually try writing programs. Okay, fine. Class ends at 8. It's 6 to 8 every week. Okay, done. Very good. We'll give 5 minutes in case people are still trying, and then we'll discuss the answer. Anyone else done with the, how many of you are done with the solution? I saw that one person said they were done. Others, are you trying? I'm giving you this time to try the solution. I hope you're all trying the question. Okay, I'm going to give you a few more minutes. Okay, good. One more person is done. Okay, I'll give 2 more minutes in case people are still trying. I only see two people who have responded with done, so I'll just show the question again. Okay. Okay, fine. Let's discuss the solution. Again, I hope if you guys haven't done it, please try it. We can discuss more. Okay, so let's first look at your solutions. So again, because it's a recursive function, you have to define the function and call it within itself, right? So, so you have divided the list into the first element and the rest of the elements. And if the first element is actually what we want, then just return the deleted list. Otherwise, return um, the plus deleted the rest of the list. So you have to just check whether the any of the remaining elements have the list. So here you're assuming that the element appears only once in the list, right? Otherwise this won't work. So this is what you're trying. Okay, fine. So that's good. That is how you do it. So here you can see that again. So if you're checking if an element is there in the full list, it becomes equal to checking if an element is there in part of the list, in part of the list, and so on. So that's how you do it. Okay. So this is how you do the question. Okay, fine. So next person has also given the same thing. So again, recursion is always about breaking the problem into a smaller subset of that problem. So let's try. Okay, I don't know what happened. I think there was some internet fluctuation. Okay, let's try looking at the solution. Okay, fine. So I'm gonna get the solution. So here you can see that again, here also you can see that we are doing this. So return delete elements input list, right? So this is what you're doing. So this is what you guys also did. Oh, sorry. So when you do this, you don't really assume that the list is that it appears only once because you're calling it here also. That's what I have also done. I am sorry. I just assumed something else. So you're call. I didn't read the function properly. So here you're calling it again. So again, if it's not the element, then you have to keep that element and run it on the rest of the list. So correct. Both of your elements lists are correct, and this is exactly what it is. So this is my input, this is my base case, right? I have to keep doing it, I have to keep doing it until I get an empty list. Otherwise it will keep going to zero, as you know. Now otherwise it will keep infinitely recursing, calling itself. So here you can see that if the first element itself is the element to remove, then I just check the rest of the elements. But if the first element does not match, then keep the first element and then check the rest of the elements. And I'm always reducing the list by one, right? So first I will just take from the first element onwards, then I'll take from the first element of that list onwards. So I'm essentially taking from the second element onwards. So that's what I mean by recursion, is to break the problem down into a smaller sub problem. So let's try doing this. So let me first just clear everything. The terminal is very cluttered. So let's run this. Let's enter 1, 2, 2, 2, 2, 2, 3, 4. Okay, 122, 2, 2, 2, 3, 4. I'm going to remove the element 2. So now you can see that the output is just 1, 22, 3, and 4, right? Without the element 2. So this is what I wanted. So again, if you have some doubt into how this is happening, try printing the list at every iteration. That will give you an idea of what is being removed and what is being kept at every iteration. What is the list like at every iteration? And remember here that I save the input into, I'm not really rewriting from it. I'm saving the input into another list. Sorry. Yeah. It's just not writing over the list. It's just returning it. So don't worry about overwriting the list. Okay, as they explained in the problem. Okay, fine. So I think, okay, we have 15 more minutes. So let's try to do the last question. This is again a recursion question. I'll again give you 10 minutes. I've seen only like one or two people actually doing the problems so far. So please, all of you try to do this problem and we can end the class. Okay. So I'll again give you 10 minutes. This question is, in mathematics, LCM is the lowest common multiple of two or more numbers, whereas HCF is the highest common factor of those numbers. You might be familiar with these from your elementary maths, right? From literally from first or second standard. You have to accept two numbers as input and write a program that uses recursion to calculate the LCM of those two numbers. Okay, so calculating the LCM using recursion. So here's a hint for you that you can use this mathematical property, which is that the product of the LCM and the HCF is the same as the product of the numbers. So please try it out. I'll give you 10 minutes and then we can end the class. Okay, someone is done. Very good. I'll give few more minutes in case people are still trying. Let's discuss the solution at like 7:50 or 7:55. Others also please try. Okay, someone has posted the solution in the chat. I was hoping we can stop. As I said, please don't do that until it's fine. I'll look at it. Okay. Okay, fine. I can see your question. So the question is to calculate the LCM of two numbers. Here you have calculated both the HCF and the LCM. Okay. Okay, fine. You guys are getting ahead of me. So maybe I will just discuss the answer. Others who have not tried, please continue trying and I'll just discuss the answer because people have already started putting answers in the chat. So here, as I said, the understanding is to use this relation, which is that the product of the LCM and the HCF is nothing but the product of the two numbers. So let's see how we can use that to do the problem. Okay. So here, nothing but here you can see that this is a recursive function because I'm using the HCF, but I'm calculating the HCF. So I know that the highest common factor of any number with 1, for example, is going to be itself, right? Sorry, is going to be 1 only. Similarly, that's why you keep recursively taking the modulus and then seeing what is the highest common factor. So you use recursion essentially in calculating the HCF. And if I have any number and 0, I know that the highest common factor is that number. So that is why this is because 0 is a multiple of every number. So the highest common factor will be itself. So I'm going to keep on dividing until I reach 0 or something like that. So that is my base case, right? And then to calculate the LCM, I just do the relation that I showed you. So HCF is calculated recursively. Because, for example, if a number and a multiple, if I have, then I can find the HCF, then I can find the HCF of, in order to find the HCF of these two numbers, I have to first find the HCF of what is what some other lower factor and so on until I get the actual highest factor. So that's how you think of breaking this down into a smaller problem. So we can see this in action with, for example, 4 and 16. The LCM of 4 and 16 is 16, for example. Similarly, if I use 5 and 7, the LCM is 35. So here again, just to explain, the recursion is used in calculating the HCF, and then we are going to use that HCF to calculate the LCM. The reason why recursion can be used to calculate the HCF is literally the highest common factor between two numbers. So if I want to find the common factor between 4 and 1, first I can find the common factor between um, uh, 1 and some multiple of 4, for example. So like that, I keep factorizing the number and then seeing what is the highest number I can get. So at any point, if I get a multiple, I know that is immediately a factor. That's immediately going to give me a reminder 0. And that's why this is my base case because 0 is a multiple of every number. Okay. So for example, in the case of 4 and 16, the HCF is actually 4, right? Because 4 divides 4 and 4 divides 16 also. So here what I am doing is first I will try 4 and 16 mod 4, which is a 0. So that tells me already that 4 divides 16. But suppose I had taken something else which was not divisible, then for example 5 and 7, which are co-prime and they are both prime numbers, is going to be 1. So 5 and 7, if I do 7 mod 5, then I'm going to get 7 again. Sorry, not 7. I'm going to get 2. Then 2 mod 5 is going to give me 1. Then 1 mod 5 is going to give me 1 again. 0. So I'll just have to keep doing it until I get 1, right? I'm not ever going to get some common multiple before 1. So that's the idea. You keep taking the remainder and seeing what is the highest common factor. So essentially, because factorizing means I'm dividing repeatedly, that means I'm dividing it into a smaller number and finding the HCF of that subset. So that's why I can use recursion in calculating the HCF. And from the HCF relation, I can always calculate the LCM. I think this is what you guys also did. Is there any doubt in this question? I think this is not very difficult. Any doubt in this question? All right. If not, we can end the session for today. Before I end, I'll just share all the links again in case you guys have doubts. So, again, we have these sessions every Monday from 6 to 8. This is the usual slot. If at all I'm busy, we'll change the slot. But mostly it will always be between 6 and 8. And this is my email id. You can mail me with any concerns in case I have missed your mails or something. As I said a few weeks ago, I found that some mails are going to spam. I am now checking my spam folder regularly, but I didn't check it over the last week. I got a little busy. So in case any of you have mailed me and not gotten a reply back, don't worry, I'll check today, and if at all it's there. If you want me to cover some particular topic in the class, please let me know a little in advance. Like if Monday's class, if you let me know by Thursday or something, I can over the weekend when I make the slides, I can include that problem in the slides as well. And apart from this, I can give you my website. So in my website, there is all the links to all the recorded sessions. So I'll just show you. So here you can see that the meeting link is here. The YouTube playlist where all the recorded sessions have been uploaded so far is here. So if any of you miss any of the classes, you can go here. And the slides of the sessions are here. So in the slides, you can also find that I have also uploaded what are the programs of each week. So last week's programs are all here. And this week after this session, I'll be uploading the video and everything. So don't worry about missing the classes. If you do, you can always access the recordings. So there is no such attendance mark or anything as far as I know. I do mark the attendance automatically because Teams does it and they ask us to submit the number. But I don't think there's any marks for the attendance or something. So again, if you can't attend any week, don't worry about it. That's why the recording and everything is done. But again, because this is a live session, because anyway your lecture videos are recorded, so this is a session where you actually can interact with me and clear your doubts on the spot. And I think it's also a good platform because I give you some time to do some programming on your own, so that at least for 2 hours every week or 1 hour every week you have some practice with programming, which I don't know if you are doing otherwise. So you can just, I think it's still worthwhile to attend the sessions, but of course, if you can't because of whatever reason, that's perfectly fine. That's why all these recordings are made available to you. So just save this link. You can always check this link for the meeting link, video link, all those things. Okay. Any other questions? Okay, if not, let's end for today. Have a nice week, rest of the week, all of you. Thank you for joining and see you all next week. Okay. Thanks, everyone. Bye.